Hello, everybody. Good evening. Welcome back. We'll be reading some of the Python Crash Course again. Jumping back in. Let's just go ahead and get started. Got some jazz playing right now to help just chill out the vibe. Where's my bookmark? That's not good. There we go. Big book. Alright. So jumping right in, I believe we left off on the try it yourselves, 969798. Yes, we are right. So let's go ahead and give these a go. So, alright, in 9-6 it says ice cream stand. An ice cream stand is a specific kind of restaurant. Write a class called the ice cream stand that inherits from the restaurant class you wrote in exercise 9-1. Okay, so let's take a restaurant class here. Let's see. Actually, let's go 9-6 dash. Ice cream stand that inherits in the restaurant class. So ice cream stand dot pie from 9 dash. There's nothing you can import from here because it's all numbers. Okay, so we have to just copy the class. From 9-1, let's copy this class. Paste that in. While I'm here, let me go ahead and pull up the chat just in case anyone joins. Highly doubtful, but just in case. Alright, so we inherit from the restaurant class, so we're going to create a new class called ice cream stand, and we're going to put in restaurant, right? So now we're going to inherit everything from restaurant, and we're going to define an init when we initialize. We're going to put self, and we're going to put that inherits from the restaurant class you wrote in exercise 9-1 or exercise 9-4. Either version of the class will work. Just pick which one you like better. Oh, 9-4 had this one, cuisine type, whatever. We'll just use 9-1 to keep it simple. Just pick the one you like better. Add an attribute called class flavors that stores a list of ice cream flavors, and write a method that displays these flavors. So we want to apply a new attribute called flavors, right? That stores a list of ice cream flavors. Okay, so we want to say initialize. Right. So actually, no, not. So we apply the same properties as the restaurant above, and then we create this new attribute, flavors, self-taught flavors, which is equal to a list of flavors, which it will have, mint, chocolate. And then we'll do that. Right? So write a method that displays these flavors. Create an instant ice cream. Call this method. An ice cream stand is a specific kind of restaurant. Write a class called ice cream stand that inherits the restaurant class you wrote in. Add an attribute called flavors to source list. So what are attributes then? This is not an attribute. What was an attribute again? A property given to self. So this is an attribute. It's a property given to the self, but you don't need a flavors to get started with the restaurant to initialize one. Right. So we call this, and we call for flavor and flavors. And self.flavors when access that specific instance flavors. Print. Let's format this \n with flavors inside. Flavor inside, right? So now let's call this method to create example 1 is equal to let's just create ice cream stand. We want to give it a name, which is going to be Michael's ice cream. Michael's ice cream. Okay, and we want to give it a cuisine type. Dessert. Ice cream. Right. So that'll create an instance of ice cream, and then we want to call. We need to give this a variable called Michael's. Just keep it consistent, and then let's call Michael's ice cream dot menu flavors. Call this method, and let's print out. This should print all our flavors. No! It's a super remover to the string. My 19 super cuisine type descriptor, and it requires a super object versus a string. Oh. I think so. Okay, so you have to include super parentheses. Now, if we run this, boom, mint chocolate and vanilla printed. That one's 9-6 done. 9 underscore 7 underscore admin dot py. An administrator is a special kind of user. Write a class called admin that inherits from the user class you wrote in exercise 9-3. Administrator is a special kind of user. Okay. 9-3, I take my user class. Give it this, and I'm going to create admin class. I'm going to give it the user as a parent. So when we initialize the class, we're going to give it a self, we're going to give it all the same attributes of that class, right? Write a class that inherits from the user inherits from the user class you wrote in 9.3, and add an attribute privileges that stores a string called can add post, can delete post, can ban user, and so on. So I want to super the init for the following. Right. But then I want to call a self dot privileges. Did I spell that? Nope. Brutal. Self dot privileges attribute. It has a list of strings. Can add post. Can delete post. Can ban user. Right. And then it wants us to define a new method. Which is show underscore privileges, and inside we're going to take self that lists the administrator set privileges. We're going to print for privilege in self privileges we want to print \tab with privilege, and then we want to title cases, right? And then we want to give it a new line. before we tab. So now if we clear this and run. Ooh. Oh, I don't have anything called. So we need to create an instance of admin and call your methods. So admin1 is equal to admin, and we're going to give it a first name of Michael, give it a last name of Deming, and give it a username of Michael Deming, and an age of 25. Hopefully it takes strings, I'm not sure. Or integers is for instance variables. And then we're gonna call the method, instance method, self.privileges on admin1. Show privileges. And then we print this. Adult. Title. Does it have to be inside? I can't remember. Yep. So now privileges compose, add post combine user. Boom. Alright, 9-8. Privileges. So write a separate privileges class. The class should have one attribute, privileges, that stores a list of strings as described in exercise 9-7. Move the show privileges method to this class. So we're going to create a new class called privileges. And it's going to take in nothing. When we initialize this class, we're going to give it a attribute of so we're going to put in actually self dot. We're going to take this, go to our admin class, go to privileges, take this actually completely. Actually going to take all of this, boom, move over to here, paste that in. So we have the privileges attribute inside here when we initialize self for privileges class, and then we have the show privileges here. Can I? Weird. Okay, so the class should have one attribute privileges that stores a list of strings, right? Yeah. Make a privileges instant as an attribute.
I'm fine. I love you too.
Everything all right?
Yes, all things considered.
Well, at least the sun is shining brightly today. Well, I mean, you got this.
Thank you, Aaron. Really.
Okay, so okay. I create an admin, and then I show privileges. Um, so I set the privileges class to an attribute of admin class. So now I can do dot show privileges now for this. Now it runs the same thing. 9-9 upgrade battery. Okay. Use the final version of electric car .py from this section. Okay. Does he have the class already? Chapter 9. Okay. There we go. So we pulled the class cars and everything from his online. So you have, when you initialize your self make model, you get descriptive name, you get read odometer, update odometer, increment odometer. Okay. So we have this. Use the final version of electric car aircraft from this section. Add a method to the battery class called upgrade battery. Method. So to the battery class here, I'm going to just truncate all of these other ones. So in the battery class, we're going to create a new method called upgrade battery. Right, it's going to take in self. This method should check the battery size and set the capacity to 65 if it isn't already. Describe battery size is 40. So, if not, if self dot battery size not 65. Uh, not equal to 65, then we want to so I want to self dot battery size equals 65. I wonder if you can do this all in one line creatively. Well, it's operator and these events need to assign a value to a variable, return it with an expression. If value if so self else pass. So if it's not equal to 65, set it to 65. If it is, pass. Right, so this method should check the battery size and set the capacity 65. Is it already? Make an electric car with default battery size. Get call range once, and then call range a second time after upgrading the battery. Get range. So then we want to my leaf dot battery dot upgrade battery. And then we want to call this one line again. So now if we run this, clear. Oh, I don't want to get electric. I don't want to call electric car. I want to call car. No, I want to call electric car. Get range. Capacity to 65. You should see an increase in the car's range. Yes. Cool. Get call range once and then get call range a second time. called getRange a second time. After upgrading the battery, you should see an increase in the car's range. So we went from 150 to 225. Boom. Alright, importing classes. As you add more functionality to your classes, your files can get long, even when you use inheritance and composition properly. In keeping with the overall philosophies of Python, you want to keep your files as uncluttered as possible. To help, Python lets you store your classes in modules and then import the classes you need into your main program. Let's create a module containing just the car class. This brings up a subtle naming issue. We already have a file named car.py in this chapter, but this module should be named car.py because it contains code representing a car. We'll resolve this by naming issue by storing the car class in a module named car.py, replacing the car.py file we were previously using. From now on, any program... We'll resolve this naming issue by storing the car class in a module named car.py. From now on, replacing the car.py file we were previously using. From now on, any program that uses this module will need a more specific file name, such as mycar.py. Here's car.py with just the code from the class car. Car.py, a class that can be used to represent a car. We include a module level docstring that briefly describes the contents of this module. You should write a docstring for each module you create. We can create a separate file called mycar.py. This file will import the car class and create an instance from the class. The import statement tells Python to import the car module and import the car class. Now we can use the car classes if we're defined in this file. The output is the same as we saw earlier. Is a module not the same? Yes, in Python, a module is essentially a file that contains Python categories. It can include functions, classes, and variables, as well as runnable code. The file name ends with .py, and the module's name is the same as the file name without the py extension. So if you have a file named mymodule.py, great, you can import the module, import my module. For my module.greet. Modules are files in Python with a module. Okay, so the same thing. Storing multiple classes, importing classes is an effective way. Importing classes is an effective way to program. Picture how long this program file would be if the entire car class were included. When you instead move this class to a module and import the module, you still get all the same functionality, but you still keep your main program file clean and easy to read. You also store most of the logic in a separate file. Once your classes work as you want them to, you can leave those files alone and focus on the higher level logic of your main program. Storing multiple classes in a module. You can store as many classes as you need in a single module, although each class in a module should be related somehow. The classes battery and electric car can both help represent cars, but let's add them to the module car.py. So let's add them to the module car.py. Now we can make a new file called myelectriccar.py, import the electric car class, and make an electric car. From car, import electric car. Or from car.py, import electric car. This is the same output we saw earlier, even though most of the logic is hidden away in the module. Importing multiple classes from a module. You can import as many classes as you need into a program file. If we want to make a regular car and an electric car in the same file, we need to import both classes. Import car, import electric car. From car, import car, electric car. My Mustang car, my Leaf, electric car. Yeah. You import multiple classes from a module by separating each class with a comma. Once you import the necessary classes, you're free to make as many instances of each class as you need. In this example, we make a gas-powered Ford Mustang and an electric Nissan Leaf. Importing an entire module. You can also import an entire module and then access the classes you need using dot notation. This approach is simple and results in code that is easy to read, but because every call that creates an instance of the class creates the module name. You won't have any naming conflicts with any names used in the current file. Here's what that looks like to import the current car module and create a regular car and electric car. Just import car, car.electric car. First we import the entire car module, then we access the classes, electric car. Okay. Importing all classes from a module. You can import every class from a module by using the following syntax. From module name import asterisk. This method is not recommended for two reasons. First, it's helpful to be able to read the import statements at the top of the file and get a clear sense of which classes a program uses. With this approach, it's unclear which classes you're using from the module. This approach can also lead to confusion with file names and with the names in the file. If you accidentally import a class with the same name as something else in your program file, you can create errors that are hard to diagnose. I show this here because even though it's not a recommended approach, you're likely to see it in other people's code at some point. If you need to import many classes from a module, you're better off importing the entire module using the module name.className syntax. You won't see all the classes used at the top of the file, but you'll see clearly where all the modules used in the program. You'll also avoid the potential naming conflicts that can arise when you import every class in a module. Importing a module into a module. Sometimes you want to spread out your classes over several modules to keep any one file from growing too large and avoid storing unrelated classes in the same module. When you store your classes in several modules, you may find that a class in one module depends on a class in another module. When this happens, you can import the required class into the first module. For example, let's store the car class in one module and the electric car class and battery classes in a separate module. We'll make a new module called electriccar.py, replacing the electric car file we created earlier, and copy just the battery and electric car classes into this file. Electriccar.py. So the class electric car needs to access its parent class car, so we import car directly into the module. If we forget this line, Python will raise an error when we try to import the electric car module. We also need to update the car module so it contains only the car class. The class electric car needs to access its parent class car, so we import car directly into the module. If we forget this, there's an error, we can try to import the electric car direct module. Now we can import from each module separately and create whatever kind of car we need. We can import car from its module and electric car from each module. We then create one regular car and one electric car. Both cars are created correctly. As you saw in Chapter 8, aliases can be quite helpful when using modules to organize your project's code. You can use aliases when importing classes as well. As an example, consider a program where you want to make a bunch of electric cars. It might get tedious to type and read electric car over and over again. You can give electric car an alias in the import statement from electric car, import electric car as EC. Now you can use the alias whenever you want to make an electric car. MyLeaf equals EC Nissan Leaf 2024. You can also give a module an alias. Here's how to import the entire electric car using EC. Import electric car as EC. Yes, EC. You can now use this module with a full name. Okay. Finding your own workflow. As you can see, Python gives you many options for how to structure your code in a large project. It's important to know all these possibilities so you can determine the best way to organize your projects as well as understand other people's projects. When you're starting out, keep your code structure simple. Try doing everything in one file and moving your classes to separate modules once everything is working. If you like how modules and files interact, try sorting your classes in modules when you start a project. Find an approach that lets you write code that works and go from there. Try it yourselves. We're almost done with the chapter here, so let's just keep grinding, I say. I'm going to take a quick 5-minute break, grab a snack. I'll be right back. Enjoy the tunes here. Is it still playing? I think so. Yeah, it is. It's just really quiet. Does turning up this on here change the OBS volume? Oh, it does. Let me turn this all the way up. Turn this down. Like so. Okay. I gotta keep the YouTube all the way up. Gotcha. Alright, so let me go grab a snack and we'll continue this in a second. So enjoy the tunes here. Alright, let's go ahead and finish chapter 9 here. Almost done. We are so close. So 9, 10. It's gonna make me import. Okay, so I'm gonna have to create a new file that is restaurant. .py, and then I'm gonna have to go. These guys in here. Right. Restaurant.py. Right. Copy this into here, to my module, and then go into here from restaurant, import restaurant as var. Import restaurant, okay. Use your latest restaurant class, store as a module, make a separate file that imports restaurant. Make a restaurant instance and call one restaurant's method to show the import method is working. So we're going to create a restaurant as restaurant. This Olive Garden, we serve Italian food. So the import statement is working. We're importing the class restaurant from restaurant module and then calling describe restaurant on our instance of restaurant. Cool. 9/11. Ooh, good. Touch 9/11 underscore touch. Okay, so we need to go to our admin here. Check this guy. Start with your work from exercise 9-8. Okay. Start with your work from exercise 9-8. Store the class user privileges and admin in one module. Create a separate file. Make an admin instance. And show your privileges. And call show privileges so that everything is working correctly. Cool. So, let's see that. User privileges, call the show privileges method. So we're gonna import admin from admin, import admin. We're gonna create an admin. First name, Michael. Last name, Deming. I'll make these lowercase just so we keep it consistent. Username. Use my YouTube username and then 25. So then we're gonna call admin1. privileges. Recall show privileges. Right. So now if we clear this guy, and we run. Oh. Run that. Boom. One more time. Boom. We got the privileges to show. So multiple modules. Store the user class in one module, store the privileges in the other. Okay. User. So user admin. So then we have this. User admin import. Okay, it still works. So then we want to make user and then admin.py. So now in this, store the user class in one module, so we're going to control the server file, create an admin instance in Chrome. I'm not going to type that out again. Give me this again. From admin import admin. Cool. So recap for 910, 911, 912. So we just used this one. We made a separate restaurant class, imported it in easy. Restaurant module, imported that in. We made, for this one, we used the admin class and imported it using our user and admin class module that we made that's combined. And then in this one, we put admin and user in their separate files. And imported that, just admin. This is probably pretty loud. I forgot to turn it down from when I came back from the break. Oh well. The Python Standard Library. The Python Standard Library is a set of modules included with every Python installation. Now that you have a basic understanding of how functions and classes work, you can start to use modules like these that other programmers have written. You can use any function or classes in the standard library by including a simple import statement at the top of your file. Let's look at one module, random, which can be useful in modeling many real-world situations. Let's make sure I don't have any calls from text. There we go. One interesting function from the random module is randint. This function takes two integers arguments and randomly returns selected integer between and including those numbers. Here's how to generate a random number between 1 and 6. From random, import randint. Randint 1 6 to it gets random number to 3. Another useful function is choice. This function takes in a list of tuples and takes in a list or a tuple and returns a random chosen element. Import choice. From random, import choice. Players import choice. This function takes in a list or a tuple and returns a randomly chosen element. So players Charlotte, Martina, Michael, Florence, Eli, first up equals choice players, first up is Florence. The random module shouldn't be used when building security related applications, but it works well for many fun and interesting projects. You can also download modules from external sources. You'll see a number of these examples in part 2 where we'll need external modules to complete each project. 913 dice. This chapter is long. We're almost there though. Let's keep grinding. 913 dice.py. Make a class die with one attribute called sides, which has a default value of 6. Make a class die with one attribute called sides, which has a default value of 6. Okay, so we're gonna make a class called die, and we're gonna have it when we initialize. We're gonna take in self, and then we're gonna have a parameter of sides, which has a default value of 6. And then a method called roll die. Self.roll. Oh no. A method. Roll die. Which takes in self. And then, right? That prints a random number between 1 and the number of sides the dice has. Make a 6-sided die and roll it 10 times. Make a class called die with one attribute called sides, which has a default value of 6. Write a method called roll die that prints a random number between 1 and 6. So from random so we'll import random, or from random import randint. So in here we're going to do randint 1 and self dot side. We need to create an instance method for this guy. taking that. And then we're going to that puts a random number between 1 and the number of sides the die has. Make a 6-sided die and roll it 10 times. Die equals die. And then die. Roll die. I don't know if it's going to be able to do this with this operator. Yeah, method's not defined. We haven't learned that yet. 5. It prints a random number between 1 and 0. It really wants us to print die 10 times. Oh. So, boom. Alright, cool. So we got random there. So now we want to create right, that's the suicide die, and then we want to do the die is equal to die 210 here. So we're gonna do die dot roll die 10 dot roll 1 2 3 4 5 6 7 8 9 10 run boom. We didn't get a 1 that time. Didn't get a 1 that time either. There we go. So now let's do 20-sided die. Do die 20 is equal to die 20. Die 20 dot roll die. And then we're going to Now you could just put a parameter in here and say like this. You could say times, right? And you could say for range times plus 1, right? You know, or just, if we're not going to use this, just do underscore. Right? And so then you could just replace these with a single print statement. Die 10. Roll die 10 times. Now this should give us the same outcome. Yeah. Right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No. So you don't need to go range plus 1. So it does do 10 numbers in the range, but it just starts at 0 into 9. So if you want to do something a number of times, you can do a range number of times and be fine. But if you want to include a value of the 10th value in something, you have to do range plus 1. Range times 1. Okay, gotcha. So that's nice. Now we can just clean that up really easy. So let's just put this here. Nice. Cool. That was dice. 9 underscore 14 underscore lottery dot py. All right. Lottery dot py. Here we go. Make a list or a tuple containing a series of 10 numbers and 5 letters. This tuple is just not repeating, right? Tuples are immutable. And order is unchangeable. Okay. What only has something, well, only has value. Set. Okay. Gotcha. So, make a list or tuple containing a series of 10 numbers and 5 letters. Okay. So, data is equal to list with 10 numbers. No. 5 numbers, so 2, 6, 3, 8, 5, 9. Okay. 9. 7. 6. 5. Yep. And 5 letters. Oh, I think it just wants to use 1, 2, 3, 4, 5. A, B, C, D. Right. Lastly, E. So then, randomly select 4 numbers or letters from the list and print a message saying that any ticket matching these 4 numbers really wins a prize. So let's want to import random. Okay. So let's do winner equals random dot choice. We're gonna put data in, and then print f string if your ticket contains winner, you have won. Right? That'll be clear. Right, so that one contained random one. So now we want to contain a new list of items. So let's use like a list comprehension here. For in data range. How many times do we want to do it? 4? Yeah, 4. Right, 4. Show me example of list comprehension. Here's an example of list comprehension in Python. It's basically list comprehension. You want to create a list of squares. the function we like to perform over what period? Okay, so we like to perform. So we like to perform random dot choice data, right? And then we like to do that for in range. We're not going to use this 4 times, right? So we're going to do a list comprehension. So you just had to do it's the function first, and then for the range, the over the course of period you want it to occur. So now if we go ahead and run this, then this should respond with a list of 4 values from our data. 5. Now I can make this a set. So this picked up, this repeats the value. Alright, mate. Saying that any ticket matching these 4 numbers are there wins a prize. You can use a loop to see how hard it might be to win that kind of lottery ticket you just modeled. Make a list or a tuple called lottery analysis.py. If you can use a loop to see how hard it might be to win the kind of lottery you just modeled, make a list or tuple called myTicket. Write a loop that keeps pulling numbers until your ticket wins. Write a message reporting how many times the loop had to run to give you a winning ticket. So let's take this, put it here. So you need to see how hard it might be to win that kind of lottery. You want to make a list or typical myTicket. Okay. Write a loop that keeps pulling numbers until your ticket wins. For in range 4. Okay, so we're just gonna copy this same list comprehension here, right? So we're gonna give random choice. Wow. Winner does not equal myTicket. Wow, winner does not equal myTicket. own choices. I can figure this out. Well, winning ticket. Well, winning ticket does not equal my ticket. We want to continue running let's just say, so we need to say, wow, true. If winning ticket does not equal my ticket, I'll to run this. While true, run this. If winning ticket does not equal my ticket, then count plus equals 1. Else break print f print my ticket is a winner. Damn, man, that many times. Boom! Boom! Oh! 700. This one was pretty close. Wow, 78? 20,000 times. 20,000 times. Holy cow. That's cool. So we created like a lottery system here. I'll do new print statement. The odds it took count tries. Okay. 36,000, 14,000, 10,000, 5,000, 72, 12,000. Wow, 11,000. Cool. You can use a loop to see how I might be able to like allow each model to make it this. Oh, my girlfriend's calling me here. Hold on real quick.
Oh, are you streaming?
Yeah, I'm streaming. Let me call you back in 5 minutes.
No worries, I'm sorry.
I'm gonna watch some TV with you.
Okay, bye.
Alright, so we were able to successfully create a while loop. While I wonder if you could say while winning ticket does not equal my ticket, count plus equals 1. Uh, So I'm gonna actually take this, I'm gonna print it into GPT, see what it tells me. You're coaching this draw random winning ticket and random comparing them until they match and kind of additionally lottery so you can break down how it works. Data holds the function values while wild loop repeatedly generates winning ticket and my ticket. Converts both tickets, and if they don't match it, increase the count. If the tickets match, the loop breaks and print the results. The output will depend on random selection, but here's an example. This code works perfectly and it keeps the number of transfer vary based on. Is there a way to make this more efficient? Yes, your consensus works, but there's no guaranteed way to make random guessing significantly faster. Since you're relying on chance, however, there are some approaches that can make it slightly more efficient in terms of performance and logic. Memorization. You can use a set to store previously generated tickets. You don't compare with the same ticket multiple times. This avoids repeating already seen combinations, but won't drastically speed up any matching because you're still relying on random choices. Okay. Switching to random sample. Just like unique values. Each ticket contains distinct elements. Okay. Limit number of iterations. The goal is to estimate how long it takes to get a match. You can limit the number of iterations to provide a maximum number of attempts to avoid an infinite loop in case the match takes too long. Okay. Cool. Last problem here, 9 underscore 16 underscore Python module of the week dot py. Jeez. All right. One excellent resource is. Oh my gosh. I want to actually go back to my lottery analysis. Perfect. One excellent resource for exploring the Python standard library is a site called Python Module of the Week. Go to Py Module of the Week and look at the content table of contents. Find a module that looks interesting to you and read about it, perhaps starting with the random module. HTTPS /py Python 3 module of the week. I like the basic styling here, HTML styling. Array, algorithms, functools, time, date, time, mathematics, concurrency, cryptocurrency, hashline, networking, IP address, socket selectors. Cool. Alright, that was all that. So, styling classes. A few styling issues related to classes are worth clarifying, especially as your programs become more complicated. Class names should be written in camel case. To do this, capitalization first letter of each word in the name and don't use underscores. Instance and module names should be written in lowercase and with underscores between words. Every class should have a docstring immediately following the class definition. The docstring should be a brief description of what the class does, and you should follow the same formatting conventions you use for writing docstrings and functions. Each module should have a docstring describing what the class is the module can be used for. You can use blank lines to organize code, but don't use them excessively. Within a class, you can use one blank line between methods, and within a module, you can use two blank lines to separate classes. If you need to import a module from the standard library and a module that you wrote, place the import statement for the standard library module first, then add a blank line and import the statement from the module you wrote. In programs with multiple import statements, this convention makes it easier to see where the different modules used in the program come from. Summary. In this chapter, you learned how to write your own classes. You learned how to store information in the class using attributes and how to write methods that give your classes the behavior they need. You learned how to write init methods and create instances from your classes with exactly the attributes you want. You saw how to modify the attribute of an instance and directly and through methods. You saw how to modify the attributes of an instance directly and through methods. You learned that inheritance can simplify the creation of classes and that are related to each other, and you learned to use instances of one class as attributes in another class to keep each class simple. You saw how storing classes in modules and importing classes you need into the files where they You saw how storing classes in modules and importing classes you need into the files where they'll be used can keep your projects organized. You started learning about the Python standard library and saw an example based on the random module. Finally, you learned to style your classes using Python conventions. In Chapter 10, you'll learn how to work with files so you can save the work you've done in the program and the work you've allowed users to do. You'll also learn about exceptions, a special Python class designed to help you respond to errors when they arise. Chapter 10. Boom. Lots of progress today. Feeling good about classes and init methods. Now, obviously, this did not go into detail about the other class properties, Ripper, all that kind of stuff. So, I'm going to need to touch up on that information. But it's really cool that we can simulate these lotteries and stuff with the information that we just learned. But that's going to be it for me. I streamed almost 2 hours tonight learning and doing Python Crash Course. Really enjoyed learning.